Hi, and welcome back! The most common problem when working with numerical data is the difference in magnitudes. An easy fix for this issue is standardization, also known as feature scaling or normalization. However, normalization could also refer to a few additional concepts within machine learning, which is why we'll stick with the terms standardization and feature scaling. Standardization or feature scaling is the process of transforming the data we are working with into a standard scale. This translates to subtracting the mean and dividing by the standard deviation. In this way, regardless of the dataset, we will always obtain a distribution with a mean of 0 and a standard deviation of 1, which could easily be proven. Let's show that with an FX example. Say our algorithm has two input variables, euro-dollar exchange rate and the daily trading volume. We have 3 days worth of observations. First day 1.3 and 110,000, second day 1.34 and 98,700, and the third day 1.25 and 135,000. The first value shows the euro-dollar exchange rate, while the second one shows the daily trading volume. Let's standardize these figures. We standardize the euro-dollar exchange rates regarding the other euro-dollar exchange rates. So, we look at 1.3, 1.34, and 1.25. The mean is 1.3, while the standard deviation 0.045. Going through the above-mentioned transformation, these values become 0.07, 0.96, and minus 1.03 respectively. Standardizing trading volumes, we obtain minus 0.25, minus 0.85, and 1.1. Thus, we have forced figures of very different scales to appear similar. That's why another name for standardization is feature scaling. This will ensure our linear combinations treat the two variables equally. Also, it is much easier to make sense of the data. The transformation of trading volumes allowed us to transform the volumes from 110,000, 98,700, and 135,000 to minus 0.25, minus 0.85, and 1.1. This makes the third term considerably higher than the average, while the first one is around the average. We can confidently say that 135,000 trades per day is a high figure, while 98,700 is low. Please disregard the simplification of having just 3 observations. After all, that's just an example. There are different strategies to deal with different magnitudes. However, standardization is probably the most common one and is the one we will employ in the practical examples we will face in this course. All right, it is time to standardize our data. Let's pick up our code from the point where we declare the independent and dependent variables. Our plan for this lecture is to scale them using the standard scalar module from SKLEARN and then create a new regression with scaled features. Okay, let's import the relevant module. From sklearn.preprocessing, import standard scalar. Please be careful with capital letters. First, we must declare a standard scalar object. So, let scalar be equal to standard scalar parentheses. Note that we have created an empty standard scalar project. There is no information in it. For those of you who haven't seen scaling with standard scalar, I will explain briefly. The object we just created will be used to scale our data. In other words, it will subtract the mean and divide by the standard deviation from each point, feature-wise. The next step is to fit our input data. We write scalar.fit x. This line will calculate the mean and standard deviation of each feature. This information will be stored in the scalar object. So it won't be an empty object anymore. It will contain information about the mean and standard deviation. This is extremely important. Whenever you get new data, you will know that the standardization information is contained in the scalar. Thus, you'll be able to standardize the new data in the same way. Remember this, as it will be very useful later on. Okay, so we have the information, but the inputs are still unscaled. We have just prepared the scaling mechanism. In order to apply it, we must use another method called transform. So, let x scaled be equal to scalar.transform x. As the name suggests, transform transforms the unscaled inputs using the information contained in scalar. In simple words, we subtract the mean and divide by the standard deviation for each feature. Whenever we get new data, we will just apply scalar.transform new data to reach the same transformation as we just did. This is the most common and useful way to transform new data when you deploy a model. Okay, enough conceptual talk. Let's check what happened. We can clearly see that all the input data has been standardized. In the next lesson, we will fit the regression. Thanks for watching.